Hi, it's HTM Hackers Hangout, May 4th, 2018. I'm Matt Taylor from Numenta, and this is your monthly update on what's going on in the HTM community. There's been a lot of interesting discussions in the community, so I wanted to highlight at least one of those in this little hangout. I've got Paul Lamb on the line with me, so we might talk over that a little bit. I don't know if you have any input, you can give it. And then I'm going to talk about a couple things I'm working on, and open up the floor for questions. So if anybody's watching right now on YouTube, type questions in the chat, and at the end of this, I'll address anything that pops up in the chat. And if you want to join and discuss, you should know how to do it if you're somebody who has wants to join. I don't know. Okay, so the first thing I'm going to talk about is this. I'm going to share my screen. Which screen? Application window. There we go. So this is, go back to the very top, from Guillaume Myrie, who's sort of a recent member of the forum, posted the big question that Jeff answered I don't know, a month or two ago, and it was this type of about V1 and transformations. Anyway, he's been involved in a lot of discussions. I think you're watching right now. Hi, Guillaume, if you're watching. Great stuff, great discussions. So I just wanted to go over this because what it looks like to me is that originally this is about trying to model a real V1 and try and get like the right mapping of retinal input in a more realistic way into that layer, and doing anything that might be V1 specific. Or I just wanted to encourage that, go for it. At least that's what this discussion sort of looks like, here, discussing how different things should be represented. We're sort of you're on the fringe of encodings. How do we encode the data coming from it? I mean, it's a deep subject. There's a lot of people and a lot of books and a lot of references in this topic. If you want to go through it, there's tons of reading. I honestly have not been able to keep up, but everybody in this, I got real interested later on. Where was it? There's some great graphics in this thread, you guys. Both Guillaume and Mark Brown have been posting some really, really nice graphics. Like, that looks great. This is a really pretty graphic. Good job. And they seem to look, they look good. And hopefully you guys are helping people understand this stuff. I'm also interested in this stuff down below here, especially about this mapping from LGN to V1. I think that's really interesting, this whole zebra pattern. I mean, there's so many problems to solve here. Anyway, I'm just trying to summarize and get a handle on what you guys are interested in. I think this is also really interesting too, the fovea stuff. Paul is, I think you've read this, but you haven't been involved in any of these experiments, have you?
No, I haven't.
Yeah, so we're on the same page. But you guys that are doing any of these experiments, these visualizations, I'd love to hear. I'd love to get in touch with you guys, maybe at another Hackers Hangout, and just discuss this, because I think I could probably crack this egg a little easier if we just had a discussion about it. That's just me. I'm going to stop presenting now. Oh no, I have a couple more things to present. So hi guys, I see people watching. No big questions, so I'm just going to move along. Okay, so I'm going to show a couple of visualizations for you. I'm working on. Hey Glenn, you're there, yay. Okay, so I'm going to show a couple of. All right. So I've been working on a couple of visualizations. Here's one. This is on building HTM systems. This is live. I'll put it in the chat room too. So it's really simple. It's just a number encoder, but it's the thing about these visualizations is I can interact with the user through the text. So I can like click this link and I can cause something to happen in the visualizations, which is really nice. So for trying to teach someone something, it makes it really nice to show them specifically, visually, this concept, you know, in vision. So I'm working on integrating this type and level. I don't know if you can see this, how well this comes across over the video, but I'm wanting to try and make all these visualizations as interactive as possible so that people reading the text can identify concepts in the text directly to visualizations. And I'm also working on some grid cell stuff too. Again, I don't know how great this is going to come across because but this is, I took some code from Mirko Glukos, who's he's a research scientist who's been working with us. And he wrote this like little simulation. This is really a simulation of grid cells. And so we've got like 3 grid cells here. Let me just turn the red one on. And this thing is randomly walking across it. If I move my mouse in here, I can take control of it. And you can see obviously where the firing fields are. And then you can turn on the other cells and see their firing fields. So I'm working on a blog post that's going to have this type of visualization. There's also this other, I'm trying to show how one-dimensional projections might sort of look like, or might look like. This is a one-dimensional projection of a grid cell, one grid cell. Its projection to a one-dimensional space, and these are sort of represent its firing fields, its potential to fire around each location. So we're taking a different view on it. So those are the sorts of things that I'm working on almost entirely right now, aside from video. Like I interviewed a neuroscientist, I haven't even edited it yet. And I have another interview with David Schneider, who's a neuroscientist at the Schneider Laboratory. I don't even know where that is right now. But that'll be next week. I'm going to interview him. So I'll have 2 interviews to edit. And then other than that, I'm working on these visualizations for more educational content. And that's what Matt's doing. That's all I got for today. So I'm going to open up the floor for you guys, Paul and Glenn. If you have anything, you can fight over the mic.
Yeah, I was going to kind of show one of the things that I got out of that V1 discussion so far, which was potential optimization to spatial pooling algorithm. Let me share my screen. All right, so can you see that?
Yeah.
All right, cool. So I did this in one-dimensional space because it's easier to depict on a page here. But you can imagine that this would be sort of this line here could be a hexagon or something, and then you project that onto a sheet of many columns. But the basic idea here is that in the traditional SP algorithm, you hold on to your potential pool and your permanences from a many column perspective. So each many column has a potential pool and permanences with its synapses. But the other way you could think of this is instead you have an axon from one of the input cells, and it holds on to a potential pool and permanences instead of the many columns. So instead of sort of seeing this as a receptive field, this is kind of the opposite. It's like a transmission field. But the benefit you have here is that you can address these on bits or this potential pool in a much smaller number of bits. This is sort of in axonal arbor coordinate space, and this could use a lot fewer bits for each synapse. And so the idea is you would take that transmission field, that potential pool, and each input cell would have a target mini column. And then you just reference, sort of from that target, you could reference all the other mini columns and sort of add one to the score if that, if the synapse was connected, right? And then so you could do that for each of the on input cells. So that gives you a couple of optimizations. One is instead of every mini column sampling from the input, you only have to take the active input cells, and then they basically are transmitting the score to the mini columns. That's one of the optimizations we had talked about in the past, but this model has that in it. And then in addition is the memory savings, because you reference each of the synapses in a lot fewer bits. I was going to put together some pseudocode. I didn't quite finish it today. I'll post that on the forum. The main thing I got to finish out is how you would apply the learning algorithm to this. And then, so once I finish that, the other thing I'm going to look at is how this could be applied to temporal memory, because you can, there's even more synapses when you're talking about temporal memory. And so the potential memory savings could be big, if you can find a way to sort of apply this. So this is, this is just one little bit of information, one little idea I got out of that V1 discussion.
That's a good idea, Paul. For the first question that comes to mind is, do you think would it be very hard to add more dendrites, more proximal dendritic segments to this model? That's one thing we don't do in our current simulations.
Yeah. So my thought, so there's kind of a couple things you could do. So this is going to how I would implement this in temporal memory, which is instead of having segments, you'd sort of have a receptive field. Well, it'd still be a segment, but the segment would have a receptive field. And so you'd have whatever cells are transmitting would have a transmission field. The receivers would have a number of receptive fields. And then you'd need, the thing that I'm still figuring out is you need some sort of a global space where you can match up the receptive fields with the transmission fields. And so, if you say, think of a cell in TM that has 3 segments, there would be 3 receptive fields for that cell.
Yeah.
You'd have
Sorry.
I'm still working it out. It's still a work in progress, that idea. But
it's interesting because we're talking about like where in the process is memory theoretically stored, right? Are we going to attach it to the front of the process or sort of the further back?
Yeah, exactly. Yeah, and you actually end up modeling both if you think about a cell having a receptive field and then another cell having a transmission field. That takes topology to kind of a whole different level than the way it's currently done.
Yeah, interesting. Well, cool. Thanks for showing that, Paul. That's a good idea. I mean, there's so many ideas like this that people could try. I mean, that's one of the things that attracted me to HTM from the beginning, was it was such a flexible theory and so many things you might do with it. And as we learn more about the brain and how things work, I don't foresee anything coming up through the experimental neuroscience research that's going to invalidate anything we've found so far about HTM, which is great. Anyway, there's been some chat activity. So BitKing or Mark Brown has been chatting, and he just mentioned in chat, because I know that some of you guys aren't going to go read this, but he's been working with Guillaume with some of those ideas in the V1 thread, and he's impressed that he's trying to get the details right, and he's hoping it will be a workbench to explore how HTM matches up with some of the more classical papers. And hopefully John Paul, he explained the optimization, but we're essentially talking about not storing all those permanences in the SP and the mini columns, or like attached to the mini columns, but attach those permanence values to the input somehow, to the axons of the input, because it's another way you could do the same thing that we're doing. So it'd be interesting to see how beneficial that type of thing is, because you should theoretically be able to do the same thing either way. Let's see. There's a little bit more chat. Go look down in the YouTube chats. I think that's retained if you want to see some of the details of Mark Brown's comments about the V1 stuff we were talking about. STRs are amazing, yes. And that's it. Glenn, do you have anything you want to talk about?
I'm still working on my project. It's my primary life project. I work on it every day, but I'm still at least 3 months from whenever it's done enough to show. But it's so great. It's so much better than even last month, but it is still 3 months from done, unfortunately.
So it goes. That's life in general, is always 3 months from done.
Yep.
Yeah, it's always the last mile, too, that takes the longest on something.
Yes.
80-20 rule. Anything else from you, Paul?
Nope, I don't have anything.
Okay, everybody, thanks for joining in the Hackout, and thanks for watching live, taking part in the chat and the HTM community. Don't forget to join our forums if you haven't already at discourse.numenta.org. That's where all of the communication happens for the most part. Take care. Have a wonderful weekend.